Momentum and impulse. A force has two jobs. How does a force change an object's momentum? Our objectives, we're going to be able to define momentum, understand the nature of impulse, calculate impulse when applied to an object by a force, and use the impulse applied to describe the change in the object's motion. We're going to relate the force of an object to an object's change in motion using the impulse momentum theorem, which we've already touched on before. So hopefully this is just an in-depth review for you. All right, vocabulary preview. Momentum is a vector quantity. Momentum is a vector, so adding to our vectors, forces, accelerations, velocities, displacements, we have momentum, a quantity possessed by a moving object. Symbol, lowercase p. Unit is the kilogram times meter per second, or a Newton times a second. Impulse is momentum given to or taken from a system by a force. Symbol, delta P, or capital J, or capital I. Units are a Newton second or a kilogram meter per second. Kilogram times a meter per second, sorry. The basic equation, impulse equals force times time. A system is a collection of objects that interact with each other in some interesting way. Surroundings, everything else that is not part of the system. Sometimes the word environment is used instead. Momentum, reviewing this important quantity that describes momentum. So a quick review. Remember that a moving object has momentum. Symbol is lowercase p. Momentum is a product of the object's mass times velocity. The units of momentum are kilogram times meter per second because this is the unit of mass times velocity. We'll also find out that newtons times second, or Newton times second, is the same thing as kilogram times meter per second. A momentum is a vector, which means it has direction. The direction of an object's momentum is the same as the direction as its velocity. So if an object moves backwards, we're going to give it a negative valued velocity and therefore a negative valued momentum. On the equation, okay, very funny. Let's go back here. On the equation sheet, it's going to look like this with the vector symbol above it. Momentum square diagrams. To help explain some interesting phenomena related to momentum, we will create something called a momentum square diagram. The diagram looks like a graph grid in the first and fourth quadrants as shown. To represent momentum, we're going to draw a rectangle that has the same width as the object's mass and the same height as its velocity. So it kind of looks like a velocity versus mass graph, but it's not. Instead, it's this much mass and this much velocity, and then you shade it in. The green rectangle, that is not green, the blue rectangle to the right represents a 3 kilogram object moving at 4 meters per second. So it has 12 kilograms times meters per second of momentum. The momentum of the area is the triangle. This square diagram shows an object that has a momentum of negative 15 kilograms times meter per second. Its mass is 5, and it's moving with negative 3 velocity, 3 meters per second of velocity backwards. Impulse is the change in momentum. It is that simple. That's it. Impulse is the change in momentum. Any questions? Just kidding. When a force is applied to an object, the force can do two things, both at the same time. A force can give or take energy from the object, or the system that the object is part of. The amount of energy given or taken is called work. We studied this last unit. It can give or take momentum from the object, or the system the object is part of. The amount of momentum given or taken is called impulse. That's the focus of this unit. Because momentum is conserved, if an object or system undergoes a change in momentum, another object or system had an equal but opposite momentum change. If a car gains rightward momentum, then something else had to have lost rightward momentum or gained leftward momentum. Only a force can transfer momentum. The amount of momentum transferred is called impulse. The amount of momentum transferred is called impulse. Because impulse represents a transfer of momentum, impulse is measured in the same units as momentum, and those units are equivalent to a Newton times a meter. If Newton times a second, That's a typo. Please don't look at that. Newton times a second. If a force F acts on an object for the time delta t, then the impulse is calculated by the equation change in momentum equals force times time, Newton times a second. Impulse is a vector because momentum is a vector. A rightward force causes a rightward impulse. A rightward impulse either gives more rightward momentum to a rightward moving object or takes away leftward moving momentum. A leftward force causes a leftward impulse. A leftward impulse either gives more leftward momentum to a leftward moving object, or it's going to take away rightward momentum. On your equation sheet, impulse is going to appear right here. Delta P equals F delta T, and that is just above our kinetic energy and below the momentum equation. So change in momentum equals impulse. Your equation sheet may have changed. At the time of this recording, there's some changes coming down from AP. Whisper that I've heard is instead of using delta P, J may be here or something like that. So just be aware that J, delta P, whatever, it's impulse.